In the research paper titled, "Less is More: Enhancing Structured Multi-Agent Reasoning via Quality-Guided Distillation," the authors present an innovative approach that secured third place in the XLLM ACL2025 Shared Task-III. This task focuses on a low-resource structured reasoning challenge, where large language models must generate interpretable, step-by-step rationales using only 24 labeled examples. The core idea is to show that working with less data can lead to better results through careful quality control and distillation techniques. At the heart of this work is the "Less is More" framework, a multi-agent system designed to handle structured reasoning tasks efficiently. These tasks involve breaking down complex questions into logical components, creating chains of thought, and verifying each step. The authors address two main challenges: the scarcity of labeled data, which makes it hard to fine-tune powerful models, and the need to ensure that the reasoning process remains consistent and logically sound across multiple modules. The methodology begins with reverse prompt induction, a technique that starts from the desired output and works backward to create effective prompts. This helps derive task-specific instructions from the limited examples available. For instance, they use this method to generate prompts that guide the model in understanding the structure of a question or reasoning chain. Next, the framework incorporates retrieval-augmented reasoning synthesis, leveraging the advanced capabilities of GPT-4o to create contextually grounded annotations. This step involves retrieving relevant information and synthesizing it into structured outputs. Specifically, for each instance, the system generates data for 3 subtasks. Question parsing, which extracts key elements like constraints, relations, and entities from a natural language question. Parsing, which breaks down the chain of thought into atomic logical statements. And step-level verification, which checks if evidence supports each inferred statement. All of these modules are fine-tuned from the Meta-Llama 3 to 8B instruct model using a unified LoRA setup. LoRA, or low-rank adaptation, is a parameter-efficient fine-tuning method that allows the model to adapt to new tasks without retraining the entire network, which is crucial in low-resource scenarios. A key innovation is the dual-stage reward-guided filtering process. In the first stage, lightweight structural pruning removes any outputs that don't meet basic criteria, such as logical coherence or format accuracy. In the second stage, reward-based selection uses metrics to evaluate semantic fidelity, ensuring that only high-quality data is used for training. This filtering combines structure validation with reward signals across few-shot and zero-shot prompts, leading to consistent improvements in reasoning quality. The authors demonstrate this pipeline's effectiveness through experiments on the shared task subtasks. For question parsing, the system infers a structured list of reasoning components directly from the input question. For unified COT reasoning, it constructs a detailed trajectory that includes parsing the chain of thought, grounding it with evidence retrieval, and validating each step. By generating and filtering data at scale, even with just 24 seed examples, the approach creates a robust training set that enhances the model's performance. In their experiments, the team compared different reward filtering strategies and found that prioritizing data quality over quantity yields the best results. This underscores the value of controllable data distillation in low-resource settings, where traditional methods like large-scale instruction tuning fall short. The framework's modular design allows each reasoning component to be fine-tuned independently, making the overall process more interpretable and adaptable. The paper highlights how this method outperformed several strong baselines in the shared task, achieving third place by improving step-level consistency and logical coherence. By integrating techniques from prior works, such as reverse thinking and retrieval-augmented generation, the authors show that structured inference can be significantly enhanced even when data is scarce. Overall, the results emphasize that in the realm of large language models, focusing on high-quality supervision through distillation techniques can lead to more reliable and efficient reasoning, paving the way for applications in real-world scenarios where labeled data is limited. The code for this approach is publicly available on GitHub, inviting further exploration and replication.